Hey there, future tech wizards! Have you ever wondered how computers think, or how your smartphone sends messages at lightning speed? The answer lies in the fascinating world of digital electronics. Digital electronics is like the nervous system of our modern world. It's the driving force behind almost every gadget we use. From smartphones and laptops to cars and even refrigerators, digital electronics makes them all tick. But what exactly is digital electronics? Imagine a world where everything is communicated in simple on and off signals, like a light switch. That's the basic idea behind digital electronics. It uses these simple signals, represented as ones and zeros, to process information and perform complex tasks. This system, known as binary code, is the language of computers and all digital devices. These ones and zeros are like tiny electrical pulses that travel through circuits at incredibly fast speeds. By arranging these circuits in clever ways, engineers create amazing things. Think about your favorite video game. All those graphics, sounds, and controls are the result of digital electronics doing its magic. In this digital adventure, we'll explore two fundamental concepts that underpin this fascinating field: multiplexers and boolean algebra. Get ready to unlock the secrets of digital electronics and discover how they shape our world. Imagine a busy intersection with traffic coming from multiple directions. Now, imagine a traffic cop directing the flow, ensuring that only one vehicle passes at a time. That's essentially what a multiplexer, or MUX for short, does in the world of electronics. It's a clever little device that acts like a digital traffic cop, managing the flow of digital signals. In technical terms, a multiplexer is a type of electronic switch that selects one input signal from several and sends it to a single output. Think of it like a switch on a railway track, allowing only one train at a time to pass through. Each input signal is like a train waiting its turn, and the multiplexer acts as the switch operator, selecting which train gets the green light. How does the multiplexer know which input to choose? It uses a set of control signals, also known as select lines. These select lines act like instructions, telling the multiplexer which input to connect to the output. By changing the combination of zeros and ones on the select lines, we can control which input signal gets through. It's like flipping switches on a control panel to direct the flow of digital information. Now that we've met the digital traffic cop, let's delve into the language that governs these circuits: Boolean algebra. Named after the brilliant mathematician George Boole, this system of logic is the backbone of digital electronics. It's a way of expressing logical relationships using just two values, true and false, represented as 1 and 0 in the digital world. Imagine you have two light switches, and you want to turn on a lamp only if both switches are flipped on. That's a logical relationship, and we can express it using Boolean operators and and not. In this case, we would use the AND operator. The lamp will only light up, output is 1, if switch 1 and switch 2 are on, both inputs are 1. Boolean algebra provides a set of rules and operations to manipulate these logical values. These rules help us design and analyze digital circuits, ensuring they behave exactly how we want them to. By combining these basic operators, we can create complex logical expressions that represent the behavior of entire digital systems. Section 4. Real-world wonders. Digital electronics in action. The beauty of digital electronics lies not just in its elegant logic, but also in its wide-ranging applications that touch every aspect of our lives. From the smartphones in our pockets to the sophisticated systems controlling traffic lights, digital electronics is the invisible force shaping our modern world. Take, for instance, the digital camera that captures those precious moments. At its heart lies a digital image sensor, a marvel of electronics that converts light into digital signals. These signals are then processed by a digital processor, another electronic brain, which adjusts the brightness, contrast, and colors to create the stunning images we see. Or consider the medical marvels that rely heavily on digital electronics. Advanced imaging techniques like MRI and CT scans use sophisticated digital systems to generate detailed images of our internal organs, aiding in accurate diagnosis and treatment. Pacemakers, tiny devices implanted in the body, use digital circuits to regulate heartbeats, keeping millions healthy. Section 5. Multiplexers in action. From remote controls to smartphones. Remember those multiplexers we talked about, the digital traffic cops? They're not just theoretical concepts. They're working hard inside many devices we use every day. Let's take a closer look at how multiplexers make our lives easier and more entertaining. Think about your TV remote control. Each button you press sends a specific signal to the television to change channels, adjust volume, or access menus. But instead of having a separate wire for each button, which would be bulky and inefficient, engineers use a multiplexer. The multiplexer allows multiple signals from different buttons to share the same transmission path, making the remote control compact and convenient. Now let's zoom in on your smartphone, a powerhouse of digital technology. Inside that sleek design, multiplexers play a crucial role in managing the flow of data between various components, such as the processor, memory, and display. They act like efficient data routers, ensuring that the right information reaches the right place at the right time, enabling your phone to run smoothly and efficiently. Section 6. Boolean algebra at work, simplifying circuits, saving the day. Boolean algebra isn't just a theoretical tool for mathematicians, it's a powerful weapon in the hands of engineers designing efficient and elegant digital circuits. By applying Boolean logic, engineers can simplify complex circuits, reducing the number of components needed, saving space, cost, and energy consumption. Imagine designing a digital circuit for a security system with multiple sensors. You want the alarm to trigger only if a specific combination of sensors detects suspicious activity. This is where Boolean logic shines. Using Boolean operators like AND, OR, and NOT, you can create a logical expression that represents the desired behavior of the alarm system. By simplifying this Boolean expression, engineers can potentially reduce the number of logic gates required in the circuit. This simplification not only makes the circuit more compact and cost-effective, but also reduces power consumption, leading to longer battery life and a smaller environmental footprint. That's the power of Boolean algebra in action. Section 7. Digital Mastery, your key to the future. As we've journeyed through the captivating world of digital electronics, we've encountered the fundamental building blocks that power our modern world. From the traffic-directing multiplexers to the logic-driven circuits governed by Boolean algebra, these concepts form the foundation of countless innovations. Mastering these concepts opens doors to a universe of possibilities. Imagine designing your own video games, creating innovative gadgets, or developing cutting-edge medical devices. The power to shape the future lies in understanding the language of digital electronics. So, embrace your curiosity, delve deeper into this fascinating field, and who knows what incredible digital wonders you might create. Keep exploring, keep questioning, and keep that spark of innovation alive. The future of technology awaits, and with your newfound knowledge, you're well on your way to shaping it.